Modern rocket trajectories, the behavior of quantum particles, and the digital processing of sound all rely on a hidden foundational code. Symbols allow us to translate the chaos of nature into the precision of logic. We use f of x for functions, e for natural logarithms, I for the square root of -1, and sigma for summations. These marks were standardized by one mathematician, Leonhard Euler. Before Euler, the scientific community lacked a unified alphabet. By providing these tools, he created a bridge that allowed scientists from different countries and disciplines to speak the same analytical language. In the early 1700s, mathematics was often clunky and heavily reliant on geometric shapes. It lacked the flexible, symbolic power needed to solve the increasingly complex problems of the Enlightenment. Leonhard Euler was originally expected to follow his father into the ministry. However, the legendary Johann Bernoulli noticed the teenager's potential during Sunday afternoon sessions and eventually convinced Euler's father that his son's true calling was the Church of Mathematics. Euler's first major breakthrough was solving the Basel Problem, finding the exact sum of the squares of infinite fractions. While others struggled with approximations, Euler proved the total was exactly pi squared over 6. This achievement secured his reputation, leading him to the Imperial Academy of Sciences in St. Petersburg, a sprawling research hub on the banks of the Never River. He immediately put his theories to work on state projects, calculating the optimal arrangement of masts on naval ships and establishing the mathematical foundations of hydrostatics. His work demonstrated that abstract analysis could be used to predict and engineer the behavior of physical systems with incredible accuracy. But Euler's productivity came with a massive physical toll. He worked across dozens of disciplines simultaneously, from astronomy and music theory to cartography. While directing a massive project to map the entire Russian Empire, the sheer volume of visual data led to severe eye strain. By 1740, the effort had cost him the sight in his right eye. The crises multiplied. Political instability forced him to move his family, and in 1771, a fire destroyed his home. Shortly after, a failed surgery to remove a cataract left him in total darkness. Euler was 59 years old. For a man whose life was dedicated to the visual study of geometry and physics, the loss of his eyes seemed to signal a definitive end. To his contemporaries, a mathematician without sight was like a musician who could no longer hear. Instead of stopping, Euler's output actually increased. He possessed a memory so precise that he could recall the first 100 powers of the first 10 members, and a spatial visualization that allowed him to manipulate complex equations entirely in his head. He worked by outlining the general scheme of a project to his assistants, who would then calculate the specific tables and compile the examples as he dictated 700-page works on lunar theory from memory. In this state of total blindness, he produced nearly half of his life's work. He used the quiet of his internal world to refine differential calculus and pioneer the new field of topology, often while holding one of his many grandchildren. By the time the physical world faded, his mental library of formulas was so complete that his rate of discovery actually accelerated. On September 18, 1783, Euler followed his usual routine. He gave a math lesson, calculated the trajectories of hot air balloons, and discussed the orbit of the recently discovered planet Uranus. That evening, he suffered a brain hemorrhage. He had just enough time to tell his family, "I am dying," before losing consciousness for the last time. He left behind such a vast backlog of research that the St. Petersburg Academy spent the next 50 years publishing his remaining unprinted manuscripts. Euler's career proved that the mystery of the natural world was actually a solvable set of functions. He integrated the physical laws of motion with the precision of analysis, showing that everything from the path of a comet to the vibration of a string could be described through the same unified system. He spent his final years proving that mathematical insight doesn't require sight. It requires the ability to see the patterns that remain when you close your eyes. Tell us in the comments which genius you'd like us to feature next.